All right, so we're going to talk about dilution. Okay, so diluting compound. Now, let's take a look at this solution. Let's say if I have a coffee cup, a solution, man, the concentration of caffeine is 10 molar. Okay, but that's really high. No way you can add caffeine up to 10 molar. Caffeine is not that soluble. Okay, but anyway, assume that this concentration contains 10 molar caffeine. Now, if I transfer, so I have a syringe, so pull up some of this solution up to the syringe. Let's say take 1 milliliter. Okay, what is the concentration of the solution in the syringe? Still the same, 10 molar, still the same, right? I haven't done anything yet. Okay, so 10 molars here, so pull some of it. It's going to be the 10 molar. If you test the coffee in the cup and test the coffee in the syringe, they're going to test the same thing. I haven't done anything yet. All right, so same solution, just take 1 milliliter out of it. Now, I want you to calculate mole of caffeine in the syringe. Can you do that? We have molarity, we have volume. Well, take a look right here. So more volume to molarity. So moles equal to MV. So that's molarity times volume, right? So plug in 10 molar. So 10 over 1,000 milliliter times 1 milliliter. You should get that number, 0.0100 mole. All right. So that's the starting mole that you have. And then I'm going to transfer the this solution right here, 1 milliliter solution, into a test tube. There we go. So we get 1 milliliter there. Okay, so what is the concentration of caffeine in this solution right here in the test tube? Still 10 molar. What we just used from the syringe, right? Just transfer right there. Haven't done anything. The amount of mole of caffeine still the same, 0.0100 mole. Now, if I from this test tube, if I add water, okay, up to 2 milliliter, basically I add just 1 milliliter of water. What is the concentration of caffeine in this new solution? Well, it's gonna be lower, of course. How much though? From 1 to 2 milliliter. I diluted by 50%, right? So the concentration of caffeine should be 5%. I will teach you how to calculate that. Okay. What about the moles? What is the moles of caffeine in this new solution? Still the same, nothing different. We have 0.1 mole earlier. Add anything else to it, well, caffeine is still in there, so it's gonna be 1 mole. Yeah? So if you want to do calculation, so molarity times volume, that's mole, right? So 5 moles per 1,000 milliliter times 2 milliliter, you get that number. Still the same number. Not like 10, it's just like 10 times 1, 0.01. Okay? Oh no, 10 over 1,000 times 0.01. Still, wrong. No, 10 over 1,000 times 1, so 1 milliliter. That's before we add water. Okay, so so from here to here, before and after, the concentration change, of course, but moles never change to that. If you go back to the syringe, mole never change. Whatever how much you take up, the mole still in there. Put into the test tube, the mole still the same mole. Add something into it. Well, caffeine didn't go out. We have nothing leaking. Caffeine is gonna be the same amount, right? But different concentration. Okay. So what I want to say is initial mole at the beginning, initial equal to mole at the final. So mole never change. And plug in right here. So mole equal to MV. So molarity, initial molarity times initial volume equal to final molarity times final volume. That's the dilution equation. Okay. And here's how we use it. Just like was it the combined gas law? P1 V1 over T1 equal to P2 V2 over T2. Same thing there, two situations. Okay. So you have 2.5 molar solution of magnesium bromide, and the volume is 30 milliliter of it. Okay. And then you dilute it to 0.5 molar. So from 2.5 molar to 0.5 molar, and the volume is, we want to know volume. Okay. So to what volume must you dilute the sample? So that's V final. And how much water in milliliter you have to add. All right, start with the first one. So what volume in here? So final volume. Well, M1 V1 equal to M2 V2, same thing. MI VI, MF MF VF, whatever, same thing. We want to find final volume, right? So I'm going to move final molarity to the left side. So MI VI over MF. Look like that. And then just plug in, guys. Mi is 2.5 molar. V is 30 milliliter. Mf is 0.5 molar. Right? Do the math there. So molarity cancel with molarity. You end up with milliliter right there. 150 milliliter. So you have from 30 milliliter at the beginning, you have to add water up to 150 milliliter. Okay, this is not the volume of water. You don't add 150 milliliter, right? If you add 150 milliliter of water, you end up with 180 milliliter total of solution, which is not. We want to add up to 150 milliliter volume. All right. So let's take a look at the picture. Okay. So at the beginning, you have 30 milliliter of this solution. You're going to add water until the volume reads 150 milliliter. Okay. That's when you dilute the solution from 2.5 molar to 0.5 molar. So how much water you need to add? 150 minus 30. That's the amount of water you have to add into this solution. Okay. All right, one more time. So what is the volume of 16 molar stock hydrochloric acid solution? We need to prepare 100 milliliter. Hold on. All right, similar situation. So what is the volume of 16 molar stock hydrochloric acid we need to prepare 100 milliliter 1 molar hydrochloric acid? What 16 times dilution, right? And how much water again? So how much water do we need for this solution, for the dilution? So first off, you need to add, to calculate how much volume, the final volume, and then the volume of water. Okay. All right. At the beginning, what we have, what is the volume of 16 molar? So we want 16 molar. That's what we want, but we don't know volume. Okay. We need to prepare. That's the second one. Second solution. 1 molar, 100 milliliter of it. Well, 5 VI, super simple there. MI VI equal to MF VF. Move MI to the other side, and then you plug in. MF is 1 molar. VF is 100 milliliter, and MI is 16 molar. Right? Do the math there. Molar cancel out, so you should get 6.25 milliliter. Okay, so that's the final volume. All right. Now, how much water you need to add? I'll take a look. All right, so we'll take 100 milliliter volumetric flask. We have a 16 molar stock. Right? So I'm going to take your syringe to take some of this, only 6.25 milliliter. We calculate right there. Put into this volumetric flask. Just a little bit of it. Okay, and then you're going to add water up to 100 milliliter. Don't add 100 milliliter water. If you do that, you're going to end up with 106.25 milliliter, which is way too much. The concentration is going to be lower than 1 molar, okay, which we don't want. So we add only 100 minus 6.25. That's the volume of water. Okay. All right. So class activity number 3. All right, you know what to do. Let's go.